Okay, now this is, are you able to, oh, I think you are not able to see my R.
No, ma'am. No, ma'am.
Let me share. Okay, now you are able to see my R.
Yes, ma'am.
Okay, so you all have your R. Let me, because I have not saved it. You saved your, all the work that you have done it yesterday.
Yes, ma'am. Yes, ma'am.
Okay,
Yes,
you
ma'am.
can
Yes, ma'am.
start it from there. I have not saved it. Let me do it. I'll just do it within a minute.
Can you, ma'am, can you please help me? I got error in this fints dot stat
Yes, yes,
function.
we'll do it again. Okay, just attach your file. And library, the package T series. Next is I have to library your F basic. And then I have to library fints. And there is one more package. My R is already having. So E1071. You just have to install it. That is a backup. Sometimes R gives you the error. So we add this package also. Okay, done. So yesterday we did that. We just make the diagram for plot TS, and let me take the variable N225. So now you can see in this diagram that you are neither having a mean to be constant, neither the variance is constant. How I came to know that mean is not constant? Mean is constant means whenever we are calculating the mean of two different time periods. Suppose in today's state, the value is rupees 10. In tomorrow's state, value is rupees 20. So the mean will come out to be 15. So whenever we are calculating the mean of two different periods, the mean should be same. And over here, you can see that if I'm going to calculate a straight line at any point, maybe at 15,000, maybe this 20,000, maybe 25,000, if I'm going to draw a straight line, all the points will not fall on that straight line. So that means mean is not constant. Over here, if I'm going to take the mean of these two prices, whatever the prices are there, the mean will be around, you can say 18,000. Over here, if I'm going to take mean of two different prices, mean will be around 20,000. And if over here, I'm going to take the mean will be around 30,000. So that means there are different means throughout the time period. So it means my data is not stationary. So the first thing is I'm going to convert my data into stationary. So what we learned that since this is a price, these are the index. This is a Japanese index, Japan index, that is a nickel. This is a Brazil, and this is Shanghai index, China's index. So we have learned we will store the variable. That means whatever we are converting into some name. So for my, you can say for my sake, what I'll do, I'll write R over there, so that I am able to recognize that which variable I am taking. Rn225 from my wordings, it means return series of N225. So this is diff log N225. Okay, I have converted the series. So now you will see that previously what I did adf.test and I calculated N225. And what I observed that my data is not stationary. Yesterday we did it over here that if H0 means data is not stationary and H1 means data is stationary. Now over here you can see that p value is more than 0.05. So we have to go with H0. That means my data is not stationary. So what I did, I converted my data into stationary. Now let's check that whether my data has converted into stationary or not. Again, adf.test. And now my variable is rn225 because I have converted the variable into stationary and I stored all the values with the variable name rn225. And this variable in terms of econometrics is known as vector. So now you can see that my p-value is less than 0.05, which means that my data is stationary. This vector is now stationary. Okay. Now, next thing. One thing you are able to know that my data is stationary. Now I can do it by pp.test also. pp.test rn225. And you can see over here also, your p-value is less than 0.01. So that means this variable rn225 is a stationary variable. And let's check it what kpss also. kpss.test and your rn225. Now you can see that p-value is 1. That is more than 0.05. And if you will look up at the H0 of KPSS, it says this data is stationary and H0 means your p-value should be more than 0.05. So in all the three cases, the tests are saying that my data is stationary. Now let's check it with the help of diagram. So again, plot.ts and rn225. Now you can see this diagram. Now from 0, if I'm going to draw a straight line, just see this. From 0, if I'm going to draw a straight line, all the values will fall on 0. That means my mean is constant. But my variance is not constant. You will see the spikes. These are the spikes, and you will not see the constant spikes throughout. Sometimes the spikes are bigger and sometimes the spikes are smaller. So this is your volatility of your share prices. So share prices are volatile. Sometimes volatility is high and sometimes volatility is less. So that means we have constant mean but non-constant variance, which means I am having a weak stationarity and my time series will run on weak stationarity. You will never find the time series data where the volatility is constant. So you have to work on the data where mean is constant, but volatility can change. Now till here it's clear. Any doubt till here?
Yes, madam.
Clear.
Clear.
All clear. So now suppose this is not a price. Let's say I'm saying that this your share price is I'm saying this is not a price. Let's say this is already inflation. I have also given you one file of Indian economy. Let's say we just change it to Indian economy. Okay, let me attach this file also. Okay, now let me check for inflation. So adf.test and inflation. Now see, you can see that this data is already stationary, so I don't have to convert it. Now suppose if this data is not stationary, It somehow comes out to be stationary, and inflation is never it in rupees or any currency. It's never in price. It's always in percentage. So what you have to do, you can store the data with, let's say, de-inflation. For my sake, for my understanding, I always use word D when I am taking a simple difference, and I always use the word R if I am taking the log difference. You can use any abbreviation, whatever you want. So it will be de-inflation diff and simple inflation. We don't have to take log. Now I have this vector is created de-inflation. Let me check whether this is stationary or not. It's obviously it will come stationary because my data is also already stationary. Now you can see that my data is stationary. So any doubt in here?
No, ma'am.
No doubt? Okay. Now let's
No
go
doubt.
with one more Excel file. I have given you one Excel file for sales detrending. Now attach that file. Now, if you are going to observe this file, so let me plot it, plot.ts, and let's say sales. Now, over here, you will observe that there is a trend. Trend means either your data will move upwards or your data will move downwards. If it is moving either upward or it is moving downward, so we can say there is a trend. Now you will see there is a trend, and the trend is also observable. In previous plot, what we did over here, this is a stochastic trend. There is no, I cannot judge the trend. It's a random trend. Prices are moving randomly. But over here, if you are going to observe, trend is there. Prices are moving upward. But I can recognize the trend. Pattern is not similar, but still pattern can be determined. I'll give you one more data. Just have there's a one inbuilt data in it, that is your air passengers. Okay. Now let me plot this. Okay, now see this diagram. This is a diagram for air passengers. Air passengers, I gave you one example that suppose in the summer season, we all are having holidays, right? So whenever we are having holidays, we all go for a trip. And whenever you are going for a trip, at that time, the trains are booked, and at that time, the planes are also full. So whenever the trains are full, or you can say planes are full, so what happens that people, that means train, government also knows that people are going to travel, and even the air company also knows that the people are going to travel. And as the time passes, number of passengers are increasing because my population is increasing. So that means there is a trend over there. But in this trend, you will observe that pattern is similar. The pattern is similar. Pattern is similar. It is increasing. There is a trend, and this type of diagram, if you are getting, this is known as your seasonal trend. If you are getting this type of diagram, this is your deterministic trend. So I think now you are able to recognize when is your seasonal and when is your deterministic trend. Any doubt in this? When is your stochastic
No,
trend?
madam.
When is your deterministic trend, and when is your seasonal trend? So now what we have to do, we have to remove this trend. And whenever we are removing any trend, till now we have learned how to remove the stochastic trend. You will get this type of diagram. That means whenever from 0 you are going to draw a straight line, all the points will fall on that straight. Now let's move how we are going to convert this deterministic trend and how we are going to remove it. That means this is my non-stationary series. Let's check it. ADF.test and your sales. This is your stationary, but still we have to remove the trend. Data is stationary, but trend is there. I have to remove it because if I put a straight line, it won't come to be 0. So let me remove the trend now. Data is stationary, but trend is there. Your data should be stationary without any trend. As I told you, we should not have a moving data. So we have to make it a constant. So let me remove that data. For that, you need one package that is known as LM test. Let me write it over here. So you need one test, LM test, one package. You can just install that package LM test.
Ma'am, what is the purpose of LM test? Could you please explain it again?
Yes. LM for LM test.
Hello, ma'am.
Yes. LM test means linear model test.
Yes, ma'am.
This is linear model.
When to do
Linear
it, ma'am?
model. Yes.
I want to ask, what is the purpose of LM test, ma'am?
LM test is a linear model test whenever we are putting any regression equation, because we are going to learn about the linear model. So we use this linear model test. Now what I have to do, I have to remove this trend, and how to remove that trend, I have to create a model. So for that, I'll require this package, linear model test. So just install that package and then library it. Done.
Yes,
Done. Can
ma'am.
I start? Okay, now what happens? I am able to understand that there is a deterministic trend and the data is stationary, but still some trend is there. So first of all, I'll calculate the trend. So whenever you are calculating the trend, again, you have to store the trend in some value. Why I have to store the trend in one value or in one vector? Because the trend is there in each and every observation. And right now, if I'll see that the sales detrending, I am having 158 observations. You can see over here, there are 158 observations. So I have to remove that trend from all 158 observations. So if I have to remove the trend from all 158 observation, I have to store all the 158 observations trend in one vector. Or you can say with the heading. I have to store everything in one variable. So that's why I'm giving the name. So you can give any name. Let's say I am giving the name trend. So I am storing the trend in this vector. So trend is equals to, now I'm creating the model. LM linear model sales, because I have to remove the trend from sales, and then you have to put a tilde sign. Tilde sign means equals to sign. And you will find the tilde sign below the escape button. In your system, below the escape button, you will find the tilde sign. Done? Now, I am giving the command that C means whenever you have to combine more data, that is named as C bind. combine it. C means combine. So I am saying combine all the trend from where? Starting from first observation. Starting from first observation till the length. Till the length of sales. Length means complete. So I have stored the data in trend. Now this is my trend. Done. And once you store the data in variable trend, the trend variable will be created over here in environmental window.
मैडम ये मेरा लाइब्रेरी IM टेस्ट इंस्टॉल नहीं हुआ है.
So just go it by tools and install packages and then write LM test. And then just install it. It will take hardly a minute. And whenever R will install or whenever the R will be doing any work, you will see a red button over here. So whenever the you will
Meanwhile, ma'am, I request you to please repeat it again for the LM function.
LM function means linear model function. So whenever we have to create any linear model we all know that whenever we are going to have any equation, that means if I'm saying x is equals to y or I am saying x is equals to y plus 1. So that is a linear function where x and y are having the power to be 1. So whenever you want to create any linear function, that means one variable is equals to something, we always use the linear model test. And over here, what I am doing, I am saying that say from the sales, calculate the trend. So sales will be equals to some value plus trend. The trend is increasing. Let's say the value is 10. Every year, the value is increased by 2. First year it is 10, next year it is 12, next 14, then 16. So trend is there. So 4 plus some trend is there. So I have to calculate that trend. So for that, I am using the linear model function. So over here, I am saying I am storing the trend in any vector. You can give the name any vector. I have just given the name trend is equals to LM linear model. Sales is equals to, instead of equals to, R will understand the tilt sign. Tilt C means combine all the trends starting from first observation till the last. So instead of word last, as I said, set to our length of sales. So whatever is the last observation, just go with that. So now it has stored the trend in the vector trend. Done. Everyone has stored the values in trend. Now what I have to do? I have to remove this trend from my sales. If I'm going to remove this trend from all these sales, my data will be you will get the data without any trend. That means now you will not get the line like this. That means it will not be going upward. It will be flat. Now let's say how to remove it. So whenever we are removing it, again we have to give some name. So let's say I am giving the name D trend. D trend means remove the trend. Now if I have to remove something, I told you that previous my one of the term is 10. Second term is 12. I know that trend is 2. Value is increasing by 2. So to remove the trend, what I have to do? From 12, I have to subtract 2 only, then I'm going to get 10. The same thing I am going to do over here. From D trend means from sales, remove this trend, you will get your answer. So I am doing the same thing. Sales minus your trend. So first of all, I have to predict the trend. So I am saying sales minus predict all the trend. Predict your trend. Now you will see that D trend is created. D trend is created over here, and now if I'm going to plot it, plot.ts, D trend. Now you can see that trend is removed. And from 0, this is 0, this is 500, this is minus 500. If you are going to draw a straight line from 0, all the values will fall on 0. Your trend is removed. Now you can see this diagram and now this diagram. They are similar, only the thing is that trend is removed. Now my data is ready to work on. Now I will be working on this data after removing the trend. In this, I don't have to make it stationary because my data was already stationary. Now, if I'm going to check this also, adf.test and dtrend. Now you can see your data is stationary. The p-value is less than 0.05. Got it? This is one of the way to detrend the series. Now I'm going to tell you the another way. Now over here you will see that I have stored my value in trend. If I'm saying I am removing the trend, it means I am telling the R, give me the residuals. Residuals means remaining part. If I have stored all the trend values in word trend, so whatever will be the remaining part will be without trend. So either you can do by this method, dtrend is equals to sales minus predict trend, or you can use it. Let's say I'll name it dtrend 1. I'm just giving another name because if I'll give the same name, it will overwrite it. So dtrend is equals to residuals and then trend. You will get the same answer. If I'm going to plot.ts and dtrend 1, you will get the same diagram. This is dtrend 1, same diagram. So it's
Madam,
up to you.
Madam,
Yes, sir. Yes, sir.
can you explain this theory, madam? Residual.
Yes. Sir, residuals, sir, what do you mean by residuals? The English meaning of residuals? Remaining part?
Yes, ma'am.
Residuals means remaining. Whatever is left, we name it as a residuals. So what I have done from this sales, I know that there is a trend. I stored the trend in the word trend. I stored all the trend in my variable trend. So if everything is stored in trend, whatever is remaining, that will be without trend. I have stored the
Yes,
trend in
yes.
trend. So whatever is remaining, that is without trend. Remaining part means residuals. So I'll just give the command that calculate the residuals of trend. Either calculate the residuals remaining part of trend or subtract trend from the sales. It's one and the same thing.
Okay.
Got it? So that means now you are able to know how to detrend the series and how to make the stochastic trend, how to remove the stochastic trend and how to remove your detrend, deterministic trend. Any doubt in these two?
No, madam.
Yes, sir.
Ma'am,
Yes.
ma'am, is this the same way I can remove the other trends also?
You can remove any trend. If it is a deterministic trend, you can determine the trend, you can remove it. But if it is a stochastic trend, always go with the log difference.
Okay, ma'am.
First of all, make the diagram and just judge it whether it is deterministic or not. But in real life, if I'm going to calculate, take the real life example, you will hardly find any deterministic trend. Everything is stochastic. Remember yesterday I did it on the first day. There are two ways, traditional view and modern view. In the traditional time, that means if I talk about 50 years back when my grandparents are there, at that time you are not having the globalization. That means you are just living in a small town, and in that small town only your vendors are there, your customers are there. That means all the suppliers and the customers are there within that small town. That means I know my customer and customer know their supplier, because you are not allowed to sell your product in some other state or some other countries. I'm talking about 100 years back. If you talk about when your this kings were there, if you have seen any movies and kings were there, they are not allowed to sell their product in some other kingdom. They charge the taxes over there. So that means at that time we can determine my sale, because I am aware about my population. Competition was not there at that time. But if I talk about in today's world where modernization is there and liberalization, globalization is there, everyone is free to enter any market. I am free to sell my product, maybe in India, maybe in US, and any throughout the world. And in these days, your internet is there where you can sit at your home and sell your product. Plus competition is there. So at this time, I cannot determine my customers. If I'm not able to determine my customers, I'm not able to determine my population, I cannot determine my GDP, I cannot determine my inflation, I cannot determine my what amount of exports I'm going to do, or what amount of imports I'm going to do, what will be my sales, what will be my turnover, I cannot determine right now. So in real life, you will hardly find any deterministic trend. Every trend will be stochastic. That was the point when I started the workshop. I told you that in modern time, everything is stochastic. We cannot determine anything. Determination was a traditional view, which is nowhere right now. Now done. Any doubt till here?
No, ma'am.
No, ma'am.
Hello.
Someone? Yes.
Ma'am, this
Madam.
sale is already
Madam.
stationary. The sales data is already stationary.
Yes.
What
Sales
if
data is already.
what if the data is non-stationary? Then
So
we have to
yes,
apply
yes. That's what you do. What you can do, if your data is not stationary, first of all, convert the data into stationary.
convert into stationary. And then if there is a trend deterministic, then we have to apply this LM test.
Yes. Or you can do, first of all, remove that trend, and after check whether your data is stationary. After removing that trend, whether the data becomes stationary or not. And if it becomes stationary, well and good. If it doesn't become stationary, just remove that trend or just make it stationary. If it is a price, take log. Yes, if it is no, if it is a price, take log. And if it is not a price, take simple difference. Yes, sir. Anyone else?
Madam.
Yes, sir.
Madam, if everything is stochastic, whether we can do research on this or
Everything is stochastic. You can directly convert it into stationary by taking log or simple difference.
okay.
Ma'am,
Okay.
Because
can
we
you
can- we
please
cannot find a
give an
data.
example of a log difference also?
Log difference is your share price, your sales.
No, ma'am. Actually,
If I
can
want
we
to see
do?
that how
Can
much
we
amount of
here?
it.
Yes. How to do that exercise? The log difference here in this R.
In this R, it's simple. Suppose this is sales. I want to calculate the returns on sales. So R sales is equals to difference of log, log, and then your variable name. I want to convert this sales into stationary and sales. So my R sales is there. Now I'll just check it whether my data is stationary or not. ADF.test and then R sales. Now my data is stationary. And if I can plot it, plot.ts and R sales. You can see your diagram. Your data is stationary. Even the trend is removed. Why? For if you are using log difference also, your trend is also removed. Because when I'm taking the log difference, I am thinking that I cannot determine the trend. You just draw a straight line. Your mean will be constant.
Fine, ma'am.
Any other doubt?
Ma'am,
Yes.
the trend equation will be same for every data. The trend
For
equals
log
to
difference. Yes,
no,
yes,
no,
it
ma'am.
will
The
be
trend.
same.
Okay, ma'am.
Trend will be same. The only equation will be same. Only the variables will be different. Suppose you have to remove the trend from turnover. So instead of sales, you just write the word
Yeah, yeah,
turnover.
understand, ma'am.
So whatever is the name of variable, you just write that name. Okay, now just tell me, whenever you are extracting data from different websites, you will not get the clean data. Do you want to understand that also, or should I move further? Do you know how to clean the data?
Yes, ma'am. Please
No,
tell
ma'am.
that concept.
Okay. So just open my Excel, your Excel file, because cleaning will be done in Excel. Over here also, I'll teach you how to clean, but first step is for Excel. I have given you one file with the name share price 2. Just open this share price 2. No, share price 2. Yes, share price 2. Yes, just open it. Please mute yourself. Open. Now in this you will see the sheet number 2. Dates are given and the China prices are given. Stock prices are given. See, in each and every country, your stock market operates on different dates. Or I can say in each and every country, holidays vary. If in my country, I am having 15th August as an holiday, so it's not compulsory that in China, also in US, also in Australia, also 15th August will be a holiday. Or I am having a holiday on Diwali, so it's not that China is also having a holiday on Diwali. So whenever you are calculating the stock price or you are calculating sales or anything else, our data will not match with each other. Because in India, let's say stock market works 5 days a week. But maybe in that similar week, China is having some holiday. So their stock market works 4 days a week. Or maybe XYZ country stock market works 3 days a week, maybe due to any circumstances, not due to your holiday, maybe any situation is there. The stock market is not working on the same date where my country's stock market is working. So we are having the different data. Now this is your first sheet is representing all the dates on which the stock market of China is working. Your second sheet, your third sheet number is having all the dates on which Indian stock market NSE is working. Now in the fourth sheet, what I did, I'll just copy and paste all the dates of China and all the dates of NSE. So now you are able to observe it. Can I start? Now in this, what you will observe that China is working on 1st April. India is also working on 1st April. China is working on 2nd April. India is also working on 2nd. China is working on 3rd April. India is also working on 3rd. But after that, China is working on 8th April, but India is working on 4th also, 5th also. So what I have to do, I have to remove these two numbers. I have to remove it. So if I'm going to do manually, it will be very difficult. If I'll go with this China, you can see that China is working. Now see over here. China is working One in China, I am having 1954 observation. But if I'll see India, in India, I am having 1994 observation. My data is still May 21, and over here also my data is still April 21. And there is a mismatch between these two data. And you will see many observation where India is working, but there are many observation where China is working. So we have to calculate the exact dates where both the countries are working. Then only I can, if I want to make a relationship between these two countries, my date should be equal. I cannot take the variable value for India on 1st April and for China on 2nd April. If I am taking any value of India on 1st April, the China should also have the same value on 1st April. Then only I can compare these two. So whenever we are going to establish any relationship, my data should be same. Now, how to do it? Now, just make one column date and over here your NSC. So what I'm doing, I am matching with, because China is having less number of observation. So I'm saying that I'll match the dates of China, because I cannot match the dates of India because India is having more number of observation. So let's go with the China one. So let me just copy this thing. Okay, now I have just copy and paste. Now how to do it? I want the values of Indian stock market on the same date where China stock market is working. So just write equals to, and we will be using the command VLOOKUP. VLOOKUP. Now, first name will be for the date for which you want the data. Now I am instructing Excel that I want the same date data from this part. So just select all the variables from NSC. Comma. Now after that, I have instruct this Excel that you have to search from NSC what is the value on 1st April. Now if you will see, the values of NSC is in the second column of the date. So just write 2 and then false. And then enter. Done? Done? Everyone got the value?
Ma'am, could you please show it again?
Yes. Now what you have to do, let me do it again. Now just put equals to and then VLOOKUP. VLOOKUP. Now first is your this cell. You will instruct that I want this G2. You have to look this cell from this. So I'll select all the data that from where I'm giving the instruction, from where this Excel has to search. Now, so we look up parenthesis start. First is G2 at G2 because this is the cell from where I have to search G, and this is the second row G2, and I'm giving the instruction search from D1 till E1994, and now you have to write 2. Why I'm writing 2? Because this is the second column from date, and then false. False means exact match. Now enter. Once you press enter, just double click this sign and you will get all the values. Done. Now you can see that on 1st of April, your NHC value is given. On 2nd April, 3rd April, and on 8th April, you can see the 8th April value is 5834.4. Here is 5834.4. On 9th, this is 5836.9, 5836.9. And over here, you can observe 3rd of May, NA. That means it is showing me that on 3rd of May, China is not working. Now you can see 3rd of May, China is working. Let me check why this is coming NA. Because sometimes you will observe that Excel will show you the term, but if you are going to convert it in CSV file, exact values are shown in CSV file. It will show the NA term. So that's why it's also showing the NA term.
Ma'am, India is not working that day.
India is not working on that day. Na? Let me see. Yes, India is not working. So that means China is these are the dates for China. India is not working on 3rd and 6th. And similarly, you will find various NA in this. And now the first step is we have to calculate the exact match. And the second step is I have to remove NA. India is not working on 11th of January, 11th of November also. If you will see, let's see 11th of November, India is working. No, this is 4th of November. Yes, on 4th of November, India is also not working. So this is the way how we are going to calculate the exact values. So if you are having n number of variables, suppose I want to study G20. I want to study the spillover effect of G20, or I want to study the connectedness of G20. I just want to say, suppose, for example, in 2007-8, there was a financial crisis which started, that means subprime mortgage started in US, but it affected all the world. So I want to see the effect that if the subprime mortgage happens in US, whether India is also affected or not. So that means I want to find the relationship. In that case, I have to have the data of all the countries. So how to match it? If I'm going to do manually, it will take lots of time. You won't believe when I started learning all this thing, I was not aware of how to do all these things. So it took 1 month to clean the data because I was doing manually. And it is hardly a minute work. Done? Can we move further? Can we move to R?
Yes, ma'am.
So now you are able to know how to calculate the exact values.
Yes, ma'am.
Excuse me, ma'am.
Yes.
Then how to remove this NA term? Like,
Yes, that's what I'm coming. Now
okay.
I have given you one data set of share price 1. This was share price 2. Now, after doing share price 2, I have make one more data set, that is share price 1. I'll just show it to you. Share price 1. Now, this is the this data set. I have taken 5 different countries. And now you will see that on 2nd of January, all the countries are working. On 3rd of January, this MERV is working, but SSCI is not working, NSC is not working, GDEX is working, HIS is working. Now, similarly, you will get various NA over here. For example, on your 25th of January, these 3 countries are working, but these 2 countries are not working. So now these are the empty cells. R will not work on any empty cell. R says that give me the clean data. If you cannot give me the clean data, give me the instructions. I will clean the data. Till here it's clear. Any doubt till here?
मैडम वो फाइल में एरर आ रहा है, एरर इन व्यू बता
In
रहा है,
which file?
शेयर प्राइस 1.
Share price 1. Yes, sir. Do it again. It won't having any error.
Import
This is a
PM.
simple
It's
Excel
fine for
file.
me also.
What you can do, you can download it again. I have mailed it to you. Just download it again and then do it. And rest of you are getting the file?
Yes, ma'am, done.
Done?
Yes, ma'am.
Anyone else is facing some difficulty? Anyone else is facing any difficulty?
No, madam.
No? Can I start?
Yes.
Okay, I have attached the file. Now, over here you can observe NA. But suppose NA is there in 8th or 9th observation, which we cannot view it because due to limited space, only few observations you can see. So first of all, you have to ask R whether there is any NA or whether there is any variable which is having the empty cell. So first instruction I am going to ask from R, any is dot NA and then the file name, that is share price 1. So I am asking R whether share price 1 is having any empty cell or not. So command is any is dot NA share price 1. So R is saying true. There are NA terms in your data set. Now, next command, I am asking how many NA terms are there. So that means sum. I am giving the instruction, calculate the total of NA terms. So sum is dot NA and your file name. So it is saying that there are 16 NA. That means 16 cells are empty. Done? Everyone is getting this?
Yes, ma'am.
Now, how to remove the NA? NA means if I have to remove these 2 NA means I have to remove the complete row. Because SSCI, that means Shanghai Stock Exchange and Indian Stock Exchange are not working on these 2 days. So I cannot compare them. So that means I have to remove this date from my data set. So this date means this is a row. These are rows. These are your columns. I cannot remove the columns. If I am going to remove the column, it means one country is being removed. So I cannot remove the column. I have to remove the row. So first of all, let me ask R how many rows are there where NA terms is there, right? So that means now I am going to say, or you can say how many columns are there where NA term is there. So if you want to see the columns, just write the columns. Column sum. I just want to ask columns is.na, command is same, is.na, and then your share price 1. Now see, it will give you date. In date, there is no empty cell. But in MERV, there are 2 empty cells. In SSCI, 4 empty cells are there. In NSC, 4, GDAX, 3, and HIS, 3 empty cells are there. Even you can observe it over here. You can count it because I have given you less number of figures. It's only 1000 observation. You can see that there will be the same number of empty cells. Now, how to remove this? Because if you are going to do manually, it will take lots of time. So just store. Again, any work you are doing in R, store in some variable. Give the heading. So let's say I'll give the heading to be X. X equals to na.omit. I am giving the instruction remove any. So command is na.omit from share price 1. It's just a simple. na.omit from share price 1. Now, if I'm going to view it, view X. Now you can see third date is removed. Let me show you this thing. Over here, you can see on the third date, NA is there, but in X, we have stored the data in X. This is view X. Let me view it again. Now, third date is removed. Or if we move further, you can see over here. Now see, 25th of January is having NA term. Now in this 25th of January is removed. After 25th, you can see 28th is there. Now this is my clean data. You will not find any NA term in this. You will not find any NA term. This is my complete clean data. Now if I ask, let me ask. Let me give the command. In X. Now false. Now X is not having any NA term. This is your clean data. Your data is clean now. Now data is ready. So what I gave you the share price data, this is your clean data. If you will observe the share price data, this is your, I have given you 3 data sets. Share price, that is a clean data. Share price 1, where the empty cells are there. And share price 2, how I converted share price 2 into share price 1. And then how I converted share price 1 into share price. And you all know how to upload this or export this file. I just yesterday told you how to export this file. So just use the command and export the file in your system. So next time, whenever you will be working, you should work on your clean data. Otherwise, every time you open your R, you have to clean your data. Got it? Any doubt till here? No doubt?
No, ma'am, no.
No, ma'am.
No, ma'am.
No, ma'am.
Okay. Now let's move to the regression part because time series is a part of regression. I'll teach you how to convert the, till now we have done how to convert the non-stationary data into stationary in R. Let me start with the regression, then I'll teach you in Stata also how to convert the non-stationary. Some command will be same. If you have observed the Stata also, if I have drawn the diagram for histogram, the command is same. Hist, parenthesis, and name of the variable is for R. And if you are working anything on Stata, hist, and then your the space and then the variable name. your stata never understands the parenthesis. That means stata will not understand the bracket. It will understand the gap between two words, but R will understand the bracket. Only difference is otherwise all the commands are same. So let me start with the regression. Okay, you can see my this screen.
Yes,
Okay.
ma'am, it's visible.
Yes, ma'am. Yes, ma'am.
Okay, regression means whenever we want to make any relationship. And whenever we want to I want to study the forecasting, either I want to study the mean, I want to study the variance, I want to study the covariance, I want to study the co-trending variables, I want to study the spillover effect, I want to study the connectedness or anything. I am making the relationship between two variables. So that means whenever we are finding any relationship among two variables, we name it as a regression line. And do you know how many types of regressions are there? When we were in school, we learned one type of regression, that is linear regression,
Linear and
OLS.
multiple.
OLS. Ordinary least square, that means linear regression. What do you mean by word linear? Anyone, what do you mean by word linear? Linear means straight line. So now we are going to do, we are having two types of regression, three types of regression. So first is my linear regression. I'll start with the linear regression whenever the line will be straight. And afterward, I'll do with the curvy linear regression. Curvy linear regression means your hyperbola. Your line will not be straight. It will be something curved. And I'm going to teach you why the curvy linears are there and why the linear thing is there. So what do you mean by linear? And what do you mean by curvy linear? So first of all, the linear regression. We will start with the linear regression. Once you are well versed with the linear, we will move to the curvy linear also. Because curvy linear is something the advanced part. Now, regression means it is a statistical procedure for predicting the impact of one or more factors on another variable. That means now I am saying when I am establishing a relationship between two variables, how one variable is impacting the other. For example, in business and financial sector, regression analysis is frequently used to determine the impact of particular input on output. So I can take the example if I want to increase my sales. So increase of sales can be depending on the advertisement I am giving. So that means advertisement has some impact on sales. Right? Or I can say I want to see the production of rice. And we all know that rice is being produced in water. So wherever you will have the heavy rainfall, you will have a good rice. So I want to predict the production of rice. So I'll see the rainfall. So how the rainfall can impact the production of rice? Or even I want to see the production of rice. One of the factor is your rainfall. One of the factor can be your pesticides, fertilizers, your soil. So that means there will be various factors which are affecting one particular variable. So in this, the variable which is being affected will be known as your dependent variable, and other factors which are affecting that will be named as your independent variables. So that means I have just given you the small example. Let's take analysis may be able to anticipate the impact of steel price on automobile sales. If I want to increase the sales of automobiles, that means I want to see whether my car, I'm able to sell my car or not. I'm going to able to generate revenue by selling the car or not. So one of the factor can be commodities went. But yes, if the steel prices are increasing, it's obvious it will affect my sales. Because if the steel price is increasing, my cost will increase. If cost will increase, I have to increase the selling price of my car. And if the selling price of the car is increasing, people are going to see their pocket, whether they are able to afford the car or not. So it will affect your sales of an automobile also. So steel price is one of the factor, or maybe suppose I want to purchase a car and I have to take a loan from the bank. And from the bank, if the interest rates are increased, so it's going to affect the sale of the automobile. So interest rate, steel price, even if the oil prices are increasing, your sales will be impacted. Maybe people can think that oil is increasing, I'm not going to purchase a car, I can use the public transport. So again, the sales will be impacted. So interest rate, your steel price, oil price, your national income, all have the influence. Maybe on the automobile of sales or maybe on the stock price of the automobile of sales. If sales is decreased, that means demand for automobile is decreasing. And if the demand for automobile is decreasing, the profit of the company will decrease. And then the stock price of the company will decrease. Everything is interrelated. So that means there are various factors which are affecting the sales. So whatever factors I have put over here, it's not compulsory that only these factors are there. For example, I have not taken the COVID-19. Suppose the interest rate is not increased, steel prices are not increased, oil prices are not increased, even the national income is not increased. But suddenly COVID came. So COVID is also impacting the sales. Lockdown is there. No one is able to purchase the automobile. Because since the lockdowns are there, many people have lost their jobs. So that can also impact the sales. But I cannot measure COVID-19. Just remember this. I'm not able to measure it. I can measure interest rate. I can measure steel price. I can measure oil price. I can measure national income. But I cannot measure COVID-19. So that means whenever we are doing the different factors which are impacting one of the factor, there can be some factors which you can observe and there will be some factors which you cannot observe. There will be some factors which you can measure. There will be some factors which you cannot measure. So the variables that is being influenced, we will name it as a dependent variable, and the other variables are named as your independent variables. Any doubt till here? Any
No, ma'am.
doubt?
No, ma'am.
Okay. Now, whenever we are doing regression is divided in two parts. One is my simple regression and second will be my multiple regression. Now, simple regression, or I can say the bivariable regression, that means now only two variables are there. Simple regression or bivariable regression, only two variables are there. Y, I will be treated as a dependent variable. R will also understand why. So whenever I'm writing Y, I've just given the abbreviation Y to the dependent variable and variable X to the independent variable. So I am saying that my equation for simple regression will be Y is equals to A plus Bx plus E. Now, what do you mean by A? A is a constant term, or I can say intercept. Your B will be your slope. That means by how much percentage or by how much amount Y is affected. If 1 unit of X is increasing, so how much Y is increasing? So that is representing by B, which is named as a slope. And E is your residuals. Now, what do you mean by word residuals? Now, I think till now you are able to understand what do you mean by word residuals. Anyone? Anyone can tell me what do you mean by word residuals? See, if you are
Ma'am,
able to know, well and good.
which is left out and unabsorbed value.
Which is left out, or you can say unobserved value. Now, what I am saying, yes, yes, error term, that's what I want to define. What is error term? Error term means all those variables which we have not considered in our model. As I told you that steel price is being affected, if I just want to learn how the sales are impacted of your automobile. So sales are impacted by advertisement also, by steel price also, by interest also. But over here, I am taking a simple regression. So I can write over here, let's say, just let me give it over here. Let's say I'm saying that sales is impacting by your A plus beta advertisement plus E plus error term. So now error term means your steel price, because I have not taken it into consideration, or your error terms means your interest rate, or your error term means your COVID-19, or it can be some other variables. There are many variables which I am not taking. So whatever variables you are taking, that will be considered as an independent variables, and whatever variables you have left out, you have not considered in your model, that will be termed as your error term. So if I want to make a good model, I have to consider maximum number of variables I can.
Ma'am, can we say error term and exogenous variables are same?
Yes, yes, you can say that.
Okay.
Even exogenous variables, we can say advertisement is also an exogenous variable. If I'm saying sales is depending on its previous past, so that is not exogenous. Otherwise, you can say exogenous variables means all those variables which we have not considered in our model. Because after that, we will learn about endogeneity also. Endogeneity also comes when this variable, that means independent variable, is related with your exogenous variables. All the variables in the error term, we name it as an endogeneity auto. Also those variables which we cannot observe. So that is mainly your endogeneity comes in your panel data. If you are doing a simple part, endogeneity won't come. But if you are doing the panel data, you have to consider all these points. So bivariate, so my bivariate function means.
Madam, just a question that you are telling that this error term, we are not considering those variables. Then how to measure it? Because we need to add it.
Yes,
So
sir.
if you
Yes,
add,
sir. We will
how to
create
measure
different.
it?
Sir, we will create different models, and after that, we are going to see which model is our best model. So that's what our research is. We will do step by step. So now, first of all, I'm creating a model with these two variables only. So if you are taking these two variables, that will be named as your bivariate. And if you are taking more than two variables, that will be named as your multivariate regression. So y is dependent on first variable, your second variable, your third variable. So as variables you want to take, you can take it. But still, if you are taking n number variables also, but still there are some variables which are sitting in your error term. Because it is not possible for each and every individual to take all the variables. Even I cannot judge all the variables. How can I judge that COVID-19 is coming? How can I judge this Russian-Ukraine war will be coming? So there are various parts, there are various variables which are sitting over there in your error term, and I cannot remember it. For example, I just give you a small example. Let's say you can just tell me that height of a child. Let's say you want to predict the height of your child. Your child is right now, let's say 4 or to 5 years of age. You want to predict his height at the age of 20, because we all know that our height is increasing till the age of 15 or 16 years. And after that, we have a standstill this height. So what will be the variables that you are going to take it? Yes, what variables you can think that the height is depending on? Let's say I'll take the first variable is height normally goes on the parents. If the parent's height is short, it's obvious that child will be having a short height. If the parents are tall, the height of the child will also be tall. So I'm taking the one of the variable is that height of a child is depending on the height of the parents. Is this the only variable I can take, or there can be some other variables also?
Yeah, there are
There
many
can
other
be another.
variables like
Can you
age.
name? So age is a factor. I'm saying at the age of 20. At the
Okay.
after the age of 20, your height won't increase.
Lifestyle, the diet.
Ma'am, food or nutrition?
Food, nutrition, anything else?
Ma'am, exercise.
Exercise. Anything else? Now see, we are not able to see where the height is depending on. You have just named three variables: the parents, your exercise, your nutrition. We are not able to judge it. Now suppose I says that there is a hormonal disbalance with the child. We are not able to recognize this hormonal disbalance, and that hormonal disbalance will be sitting in your error term. There can be many other factors also that are sitting in your error term. See, height, color of a child not only depends on your parents, it depends on your generations. Maybe your three times back, your great grandfather height is small. That can also affect your child's height. So there can be various factors which we are not able to interpret. So all those factors which we are not able to interpret are sitting in this error term. So now what we have to do, we have to create such a model where I can take maximum number of variables and least number of variables should be sitting in your error term. And that can be solved with the help of a regression. Regression can tell me that how many variables are able to explain this y. If I just want to see the height of the child, how many variables are explaining? It can happen that the height of the parents are playing a major role throughout all the variables that I am taking. So I have to calculate which variable is playing a major role in explaining the y variable. Any doubt till here? No doubt? Now see, we have two types of test, parametric test and non-parametric test. Parametric test means all those tests which are based on assumptions. And non-parametric test means that tests which are not based on assumptions. And whenever we are doing regression analysis, regression is based on some assumptions. So regression will be your parametric test. So let's move towards my assumptions. Now, first assumption is that the coefficient of independent variables and dependent variable must be having a linear relationship. Linear means there must be a straight line. Whenever I'm making a diagram, there must be a straight line between your dependent and independent variables. Your residuals, that means your all those terms that are sitting in your error term, they should be normally distributed. The residuals variance is constant for all values of independent variable x. That means I can say that all the residuals should have a homoscedasticity. There is no autocorrelation between errors. There should be less multicollinearity. And the mean of the error terms of all values should be 0. So these are some of the assumptions which we have to see. Now I'll move one by one with all these assumptions. Now, if you have observed that almost all the all your observations, or you can say all your assumptions are related to your error term. If I'll move back, you will see all are residuals. Residuals. No autocorrelation between errors. Errors means residuals. Zero mean of error, residuals. That means my all the assumptions are related to residuals. If you are fulfilling all these assumptions comes to be true, I can say that my linear regression is blue. Blue means best linear unbiased explanations. So if your all the assumptions comes to be true, then only my linear regression will be blue. Otherwise, I'll get the biased results. Now, first thing, my linear relationship. Your independent and dependent variables should have a linear relationship. Now let's move to the R and let's see how we are going to do it. Okay, let me just have my file Indian economy. Okay, done.
Yes, ma'am.
Okay, now how to create a model first. So again, if I'm going to create any model, I have to give some name. So let me give the name model only. So model is equals to LM. I've already libraried the LM test, so I don't need it again. So whenever we are creating the linear model, whenever we are creating any regression equation, we will use LM test. First of all, I'll teach you how to make a model for bivariate and then how we are going to make it for multivariate analysis. So LM. So over here, let's see that your FDI. Let's say I'm saying that your foreign direct investment is depending on your exports, imports, and inflation rate. So my dependent variable is FDI. So first of all, write FDI, then tilde sign. And after that, name of the variable. I'm saying it's depending on my exports. So if your bivariate, only two variables are there, just close it over here. Your model is created. And if you are having more than two variables, let me make one more model. I'll name it as model 1 is equals to LM. Your FDI is depending on your exports, your imports, and your inflation rate. So I have created two models now. First of all, I am saying FDI is only depending on exports. Now I'm saying FDI is depending on your exports, on imports, and inflation rate. Now let's see our results. So whenever you have to find the results, you will write summary, model, because I have stored the values in the vector model. So model. Now you can see the summary when I have taken your FDI is depending on your exports. So it has given that exports. Now see, you can see that the values are in exponential terms because I have not used the command options. Yesterday I told you if you want to remove this word exponentials, you have to give the command. Let me give the command options. Skypen is equals to 999. Now let me give the same command again, summary model. Now you can see the exponential term is removed. Now you can see over here, the export is 0.0001528 and your t value or even your p value. Either you can compare it with your t value or you can compare it with your p value. They both will give you the same result. If your p value is less than 0.05, it shows that export is playing the role. That means export is significant in explaining your FDI. Or you can say FDI depends on export. If the value is less than 0.05. But over here, my value of exports, P value of export is more than 0.05. So I can say that export does not play any role in explaining FDI. For example, if I have given you the height, how the height of your child is dependent, and I take one variable, height, my height. So it's obvious that my height has no relationship with the height of your child. So that means if I am taking one of the variable to be my height, so that means my model is wrong. My model is not playing a significant role because my height has no role in your child's height. So the same way over here, exports is value is 0.751, which is more than 0.05. So export is not significantly explaining the variable FDI. The second way you can see the t value, if t value should be more than 1.96. T value over here is less than 1.96. So that means export is not significantly playing any role in explaining the FDI. Okay, now let's make a summary of the model 2. I have created two models over here. Model 2. Model 1. I have given the name model 1. Now you can see over here. Exports, neither export is playing any role, neither imports are playing any role, neither inflation is playing any role. So that means I have to search some other variables which must be playing any role in explaining the FDI. Got it? Any doubt in here? Any doubt?
No, ma'am.
Ma'am, can
Madam,
you
this
show the model
standard
again?
error,
Yes, sir.
the standard error, could you explain, please?
Yes, sir. Standard error, we are going to explain it. I'm going to explain each and everything in a regression. If you are able to understand regression, that means my 50% or you can say 80% work is done for the time series. Now see over here, standard error means the whenever you are creating any model, error should not be there. For example, I just give you a small example. I'm cooking a food. I want the food to be tasty. And if the food should be tasty, all the ingredients that I am putting in the food, that should be properly put over there. So if my error should be minimum, if I'm putting any ingredients or if I'm putting, let's say, spices over there, the more spices are there, that means I'm spoiling that model. I'm spoiling that food. So error should be minimum. So the same thing over here, it is explaining the error should be minimum over here. So whenever we are creating model, we will see whether my error is more or not. If you are seeing any model where the error is more, that means you have to recreate the model. Now, how I'm going to say that whether my model is good or not, you will see, observe over here your R square and adjusted R square. Over here, your adjusted R square, whenever you are having more than two variables, you have to see adjusted R square. And if only one independent and one dependent is there, you can just see the R square. Now over here, if I'm saying adjusted R square, it is showing me that only 0.4% these variables are explaining only 4% of the dependent variable, which is very less. My R square, adjusted R square should be maximum. And over here also, you will see the p value is more than 0.05. That means my model is not a good fit. There is some error in a model. Everything is showing me that there is some error in a model. That means if I am taking these variables, I cannot create a model. Some other variables should be there. And whenever we will be doing further in the regression, there will be various terms, MAP, MSC. So we will be learning about the various terms, that how can we prove that whether the regression is a good fit or not. So in this, I can say that my regression is not a good fit. First of all, my model is not good. So I'm not checking the assumptions also. If my model is good, then I'll go with the assumptions, whether my assumptions are true or not. If my assumptions are false, I have to rectify those assumptions. So can I start with the first assumption? With this data only, I know that my model is a not good fit, but still just to teach you, I can just go with the assumptions also, whether my assumptions are good or not. So the first assumption is that they, yes, sir.
Ma'am, can you show me the equation of model 1?
Yes, sir. This is your equation of model. Now, I can teach you how to write the equation over here. You can just see how we are going to write the equation. Let me open one script. Okay. Now over here, I am saying I have taken FDI. FDI will be equals to your constant intercept is 24,2407.53 plus 0.00001528 exports plus E. So this is the equation how you are going to write it. If there is a bivariate, if there is a multivariate, if this is your multivariate, just write all the estimates over there and you can write the equation. Over here, my equation is not a blue. I'm not getting the biased result. They all are unbiased result. Okay, let's start with the first assumption. First assumption says that there is a linear relationship between variables. So first is there is a linear relationship between variables. So how to do it? Now I have already created a model, and whenever we are learning the assumptions, we learn that there should be mainly all the assumptions are based on your residuals. So what we have to do, first of all, I have created a model. Now I have to make a residuals also. I have to create a residuals. So how I'm going to create a residuals? Let's say I'm residual model 1. I'm just giving the name residual for model 1. I will be creating residuals for model 1 is equals to residuals and model 1. Now you will see over here the residual is created. My E term, whatever the E term is there, I have created my residuals. All the residuals are stored in this. Now what you have to do, you just have to plot it. Plot residuals, model 1. Now you can see this. Are you able to see this plot? Now, are you able to see any pattern over there? if you are able to see any pattern, that means there is now if you are able to see,
Madam, it looks like they are in a range.
okay, so if you are going to see any pattern, it means there is a non-linear relationship. And if you are not going to see any pattern, there is a linear relationship. So if there is a straight line, there will be a linear relationship. But if it is a curvy linear line, there will be a non-linear relationship. Now let's plot the line also. So what I'll do, I'll just give the command plot model 1 and 1. Now you can see over here. If I'm making the plot over here, you will not find a straight line. The line is there and then some curve is coming and then the straight line. So it means the variables, all the independent as well as dependent variables are not linear. They are curvy linear. It is observed. We can observe over here. They are curvy linear. There is some pattern. All the variables are over here. It's making some pattern. If you will observe this, there are some smiley faces there. Curvy linear. So that means my first assumption is not full. Any doubt till here? Any doubt? Second assumption says that your residuals should be normally distributed. Your residuals should be normally distributed. So how we are going to make the diagram? We will see it by histogram, hist and residuals. We have stored the value under residuals under model 1. Now you can see over here. It's not normally distributed. There is an outlier over here. So my second assumption is also not fulfilled. Any doubt in here? Any doubt?
Madam, for what
Yes.
these assessments?
Yeah, what?
For what this assumption is required?
These are the basic assumptions of the regression equation.
Okay, okay.
So whenever we are seeing that whether one variable is depending on the other variable, or I can say that all the independent variables as well as the error term is playing any role in explaining the dependent variable, it is based on some assumptions. Let me give you one more example. Let's move to my regression part only. Let me move to okay. Now, are you seeing this example? Over here, I have made a regression equation. I have said that heart disease, if I am having some heart disease, it is depending on the high blood pressure. That means if the BP is high, it's obvious that the person will have a heart disease. If a person is having high cholesterol, it's obvious person will have a high heart disease. Even if you are smoking, you will have a heart disease. But as the age increases, the chances of heart disease increases. Even if you are having a family history, there are family history says that people are having heart attacks in the family. So heart disease can be possible. If you are having diabetes also, heart disease can be possible. Obesity, if you are obese, you can have a heart disease. And if you are consumer of alcohol, you can have a heart disease. But beyond this, there are various other factors also. which are sitting in the error term. So I cannot say that only these factors are affecting your heart disease. But now if I want to see that if a person smokes, whether the chances of heart disease increases or not, how much the smoking plays the role in heart disease. But over here, you will see that within these variables, smoking and high blood pressure are interrelated with each other. Now see how they are interrelated. If you will observe your cigarettes, if you have ever seen the cigarettes, what does the cigarette contains? What does the cigarette contains?
Nicotine.
Nicotine.
Yes, cigarettes have the carbon monoxide present in them. And what is the role of carbon monoxide? When the carbon monoxide is present in cigarettes, and whenever you are consuming the cigarette, maybe you are a passive consumer or you are an active consumer. Whether you are consuming or a person sitting nearby you, he is smelling your cigarette. So that means the person sitting nearby you is a passive smoker and you are the active smoker. So whenever the person is having the cigarettes, that carbon monoxide is going inside you. And whenever that carbon monoxide is going inside you, that means it is mixing in your blood. And whenever that carbon monoxide mix in your blood, so your oxygen level decreases. That carbon monoxide reduces the oxygen to travel in the blood. And if the oxygen is not traveling in your blood, it's 100% sure you will have a high blood pressure. And the same case is with your alcohol also. So that means I can say that smoking is related to high blood pressure. If the person who smokes will obviously 100% sure that he will have the high blood pressure. Now, if I want to see that how much smoking is impacting, whenever we see that how much one variable is impacting the dependent variable, we have to consider that all other variables are constant. Now, I cannot consider the other variables to be constant. If I am a smoker, it's obvious that high blood pressure will increase. More and more I smoke, more and more blood pressure I am having. So if these two are related, how can I explain how this one variable is explaining the dependent variable? It will be very difficult for me. So now what I have to do, I have to remove this one part. So what the doctors do, whenever you say to the doctor you have a heart disease, first of all, always doctor try to say you have quit the smoking. If you are a smoker, I'm not going to treat you. Or he will try to control your blood pressure. Because if you are having a heart attack and you are having a high BP, the surgeon cannot do the surgery with the high blood pressure. They will control the high blood pressure or they will control your high cholesterol. So these are the various factors which we are doing in your real life examples also. So we have to remove one part. Either remove the high blood pressure or quit your smoking if you want to cure your heart disease. And the same thing we are doing in regression also. Whenever I have to see that whether smoking is playing a major role in heart disease or high blood pressure is playing a major role in heart disease. So first time I create the model with the smoking only. I will not take high blood pressure. And the second model I will create by taking high blood pressure by not taking the smoking. Because if I'm taking both the variables in one model only, they both will correlate with each other. They will not let me explain which variable is creating or which variable is playing a major role in explaining the heart disease. So that means there should not be correlation between the independent variables. These variables should not be correlated. They should be a unique variables. If these two are correlated, it will be difficult to explain the dependent variable. So this is one of the assumptions that there is no correlation between the dependent variables. Any doubt till here?
No, madam.
No.
Okay, if I go with the next assumption says that there should not be autocorrelation between errors. That means whatever error in whatever variables are sitting in the error term, these error terms should not be related with each other. That means today's error term should not be related with the previous day error term. That means sale of a product. I am saying the sale of a product is depending on marketing strategy of a company, your technology and automation, your availability of finance, how much money you are having, how much money you can invest in your business. That also affect the sales or ability to tap the digital footprints of the customers. How many customers are having a digital footprint? In today's date, we can name it as a digital footprint. Otherwise, how many customers are entering in your showroom? How many footfall is there? So that also depends the sale of your product. But you will see I have not taken one major factor, advertisement, over here. So that means my advertisement is sitting in my error term. So let's say I'm saying the product in today's date, I am naming it as a today's date. So let's say I'll take today is we are starting in September. So I want to see the sale of September 23. So marketing strategies, whatever marketing strategies I am having in September and whatever technology I'm using in September, or you can say whatever finance is available in my September, that's also depends. And whatever the digital footprints are there in September, that all affects my sale price. But in my error term, there is one variable that is advertisement. So I can say advertisement of September, but I am not sure that if I am giving advertisement in September, that is only advertisement that is affecting the sale of September. It can also happen that the advertisement that I gave in the month of July, that is impacting the sale of product in the September. If this is a case, that means advertisement given in July is affecting the sale of September. So that is known as autocorrelation. That today's advertisement is having the impact or having the relationship between the previous month advertisement. So over here, this is known as lag 2. Today is September. Lag 1 will be previous month is your August and 2 months back is your July. So this is your lag 2. That means the advertisement that I gave 2 months back is affecting the today's sale. So there is an auto correlation among the error terms. So how we have to do it? We have either take one of the term as an independent variable. That is the only solution if you want to remove the autocorrelation among the error term. And you will see mainly these terms are there when we are doing the ARIMA model. Next model, how we are going to predict that ARIMA model, how we are going to forecast the things. You will see the error term. If I want to see the sale of what sale will be there in the month of, let's say, December. So again, this is going to affect my sale of the December. So it can happen by today's advertisement, whatever advertisement I am giving in today's date, that can affect the sale of the December. So that is known as autocorrelation, when today's variable is depending on its past. So there are various tests through which we can know that whether there is autocorrelation or not. So whatever assumptions we are having, these assumptions should be fulfilled. That means there should not be any autocorrelation. There should not be no correlation between the independent variables. We can name it multicollinearity should not be there. Homoscedasticity. Now, homoscedasticity should not be there in the residuals. Now, let's say I'll just give you a small example. Marks of a student. Marks of a student depends on the time spent on the study. I have just taken these two variables. So that means if a student is devoting more time on the studies, marks should be increased, isn't it? I say that I am getting 0 right now. Out of 10, I am getting 0. If I study 1 hour a day, my marks are increased to 2 or 3. If I devote 2 hours a day, obviously if I'm learning more, my marks will increase, isn't it? Will this be there or not?
Yes, ma'am.
But do you
Yes, ma'am.
think this is the only condition? See, I am having 2 kids, right? My son, more and more time he devotes to the studies, he gets more and more marks. So for them, I can say that marks of a student are directly related to the time spent. As more and more time he spends on the studies, more and more marks he gets. Now let's talk for my daughter. You won't believe she studies only hardly 10 to 15 minutes a day and she is getting 100% marks. So how can I say this equation is good? She is spending less number of time, and sometimes it happens that in the exam she never studied, but still she is getting 100% mark. So I cannot consider this thing that as the person is spending more and more time on the studies, student will get more marks. Or let's take one other example. I say that today is your exam and somehow paper is leaked and you are able to grab the question paper. You know the question paper in advance. So in that case, you don't have to study more. So since the questions are there in front of you, you just remember, you just cram those questions and go to the exam and put the answers over there in your answer sheet. So in that case, less time you spend, more marks you are getting. So this situation is, I can't say that this situation is possible. So whenever the situation is possible, we name it as a homoscedasticity. And whenever this situation is not possible, we name it as a heteroscedasticity. Homo means same. That if time is increasing, marks are increasing. If time is decreasing, marks are also decreasing. If the same situation is there, that will be named as homoscedasticity. And if time increases but marks doesn't increase, it can also happen. A person is there, a student is there, he sits the whole day in front of the books, but still marks are not getting. So more and more time he is spending, but marks are not increasing. So that means heteroscedasticity, difference is there. You are spending 2 hours, marks are increased by 10% only. If you are considering that 10% increase in time should be 10% increase in your marks, but that is not happening. Or let's say the example of expenditure and income. Let's say my income is 100 rupees and my expenditure is 50 rupees. That means 50% expenditure. Now my income is double. Now I am earning 200 rupees a month. So do you think my expenditure should increase to 100? If my only expenditure is on food, previously I'm spending only 50 rupees on food. Now since my income is increasing, I will eat double. No. So it can be possible that income is increasing by 10%, expenditure might increase by 10%. But it's not the only possibility that if income is increasing by 10%, expenditure will also increase by 10%. My income increases by 100%, my expenditure increases by 10% only. Let's say if my income is 200 now, and my previous expenditure on food is 50 only. In today's date, it can be 60, it can be 70. I just increase my expenditure on food, or maybe I increase the expenditure on the clothes, but it won't be the same as your income increases. So when there is a difference in these two, we name it as a heteroscedasticity. And if it is same, we name it as a homoscedasticity. So homoscedasticity should be there in residuals. Heteroscedasticity should not be there. And whenever we will be learning how to solve it, in homoscedasticity, you will not find any pattern. But if the residuals are in the heteroscedasticity term, you will find a funnel-like shape, or you can say fan-like shape. And there are various tests by which we can find out whether there is a homoscedasticity or heteroscedasticity among the residuals. This is normally distributed that we have already done, because the data should be normally, there should not be any outliers in your data. I yesterday gave you this example for outliers, that for the example for that I took it for your auditorium whenever I have to make a sitting arrangement. Let's say if I am having a plane, I want to arrange the seats over there in plane. As more and more seats will be there, more and more revenue will be there. So I have to remove the outliers from that. If a person is having a 7 feet height, if I include that person, the less number of seats will be there in an airplane. Less number of seats means less revenue. So remove the outliers, your data should be normally distributed. So that's why it's saying the residuals should be normally distributed. Whatever amount, whatever variables are sitting in your residuals, that should be normally distributed. And we have different kinds of tests by which we can find out whether my data is normally distributed or not. And one more over here, I have not included in the slide. Your residual should have a 0. That means we need that there are less than less number of residuals, less than less number of variables should be set in a residuals. If I am able to calculate all the variables which are affecting my dependent variable, I should take them in the model. Because as more and more variables you are taking, more and more R square will be there, and your dependent variable will be explained in better way as compared to less variables. But it does not mean we are taking those variables also which are not explaining the y variable. As I gave you that my height will have no role in the height of your child. So if I am including my height also in the regression equation, that means I am just making the R square increase. That's why I'm taking one more variable. So any doubt in this?
Madam, explain R square, madam.
R square, sir, I'll explain each and everything that how we are going to calculate it with the help of R, with the help of Stata, with the help of Excel. So don't worry about that.
Okay, ma'am.
So any doubt? I'm just stopping the recording. You can ask me the doubts.